Good afternoon, everyone, and welcome to the NDA Bursary Scheme webinar on waste packaging and storage. My name is Lorraine McDermott. I'm a project manager at the National Nuclear Laboratory, and I'm joined at Chadwick House with Lindsay Rome, who's a project engineer. I've just have some general housekeeping activities to go through before we start the presentation this afternoon. The webinar is being recorded and is a public forum, so please respect that the presenters may not be able to answer your questions, and we will take those away and answer them online after. Please can I ask all participants to remain muted until the end of the presentation session. All questions that can be addressed will be done so in a questions and answers section this afternoon. So you could use the Blue Jeans software functions to type in your questions. And if you keep your microphones muted throughout the presentation, to unmute them afterwards, it's *4 to get involved in the discussions. So I'm doing the introduction today on behalf of Rick Short, who is unable to join us this afternoon. So I'm going to proceed through the slides prepared by him. And then that takes about 5 minutes. Following on from that, I will then introduce the presenters, our technical presenters this afternoon, and then we'll open up to a question and answer session. Please bear with us as we're having a few technical issues our end this morning. Right, so why does the NDA support PhD research? So this is all about maintaining and development of key technical skills. So that's to support the delivery of the NDA mission, to assist with the decommissioning activities that are planned, and for that academic experience into the NDA estate and the issues that are currently there. It's also to provide fundamental understanding of technologies and processes across the NDA estate. So in terms of waste package and storage, that's understanding the behaviour of the containers and their contents in the long term. It's to develop early stage technologies. It's TRL levels 1 to 3. So innovation is encouraged in NDA funded projects, and it's also to encourage knowledge transfer. Now that's a two-way process. So that's between industry learning from academics and the other way around. All PhD students get an industrial supervisor to support them during their studies. And one of the key things that the NDA are interested in is the benefits realised to the NDA estate. So I'll go into those a bit more detail in further slides. So Bursary call in regards to the NDA R&D strategy. So this slide has been prepared to provide a comparison between kind of the PhDs that NDA are interested in funding and those that would be funded by the site licensed companies. So on the left-hand side of this slide, you have the NDA direct research portfolio. So here the focus is on maintenance and key skills capability, to support strategic decisions and to encourage innovation. So this links to that fundamental understanding of the science behind decommissioning activities that are taking place. In comparison to that, we have the site licensed company funded PhDs and funding research opportunities. So here, these are focusing on improving the baseline for the site cleanup. It's needs driven and plant specific, and it's to maintain a specific capability. So these kind of research opportunities that are funded are more about development of technical leads, and those are not going to be pursued through this NDA bursary call. So this is to provide you guidance that your PhDs and your proposals that you're putting forward needs to link to the NDA strategy, which was published in April 2016, and pick up the innovation and those kind of strategic kind of elements within it. The next slide is on the ultimate aim and the importance of research and development in terms of cleanup of the civil nuclear sites. So on this slide here, you have an abstract taken from the NDA annual reports and accounts. And by funding PhD research, the NDA hopes to see a reduction in the numbers that are documented here. So that could be in savings to the taxpayer, in a reduction in timescale, and any kind of small kind of saving could have quite a big impact for the NDA estate. So here they're looking to make sure that the research that's done is applied, and that benefit is obviously there for the estate, and the development of new technologies and those efficiency savings are all captured as well. So this is their ultimate aim as to why they are funding PhDs through this bursary call. So my introduction there was to give you a brief background into what the bursary call is about. So now we're going to go on to the theme of this afternoon, which is waste packaging and storage, with the technical leads, and then we'll go to a questions and answers session. So this afternoon we have Martin James from Radioactive Waste Management Limited as a technical lead and a presenter. We also have Lisa Maxwell from Sellafield Limited, and we're also joined by Matt Buckley from the NDA, who's here as a participant in this afternoon's activities. Thank you very much. I'll hand over to Martin and Lisa.
Hi there, I'm Martin James. I'm an inventory manager at Radioactive Waste Management Limited. I'm one of the co-chairs of the Waste Packaging and Storage Group. Lisa Maxwell from Sellafield is the other co-chair. Do you want to say hi, Lisa?
Hello, I'm Bunny from Sellafield. I'm just recently taking up the mantle within this working group today.
Okay, so I'm only dialing in, so I'll just shout out the slide number as we go through it for you guys to change it on. So slide 7 is just an introduction to us. We are a working group reporting to the NWDRF, that's the Nuclear Waste and Decommissioning Research. That's an industry-wide coordination body for R&D that's carried out in support of the UK decommissioning programme, and it reports to and advises the NDA Research Board on the long-term research needs. There are various waste working groups that have been set up to help deliver its remit. Waste Packaging and Storage Working Group is one of those. We've got our objectives listed here. We've got 3 key points. The first one, to establish and maintain a cross-industry technical community with an interest and expertise in the conditioning, package and storage of nuclear waste. Secondly, to deliver a targeted program of research that enables improved delivery of the NDA mission by identifying common issues, opportunities and technical risks. What we mean by that is applicable to the wider NDA estate, not to just a specific site, and developing research proposals to address those issues. We also have an objective to share information and experience that leads to more effective programs within individual organisations and improve technical coordination across the industry, essentially sharing learning and dissemination of the information. Slide 8 gives us an overview of the activities of the working group. So we meet 3 times a year. That's all the members plus any institutions that have been invited to host. So we change our location every time, and any invited speakers as well. Our activities include review of NDA PhD bursaries, so that's related to what we're talking about here, and any other PhD initiatives. We also produce and review DRP, that's direct research portfolio, I think, proposals, and support cross-industry learning and sharing of best practice. The list of our members here, the various site license companies, as Lisa's pointed out to me, we've missed off a key player there, Sellafield. So in addition to DSRL Doonray, that is LLWR, Magnox, and RWM, there's Sellafield, the various different regulators, NDA, and any others. And those others include MOD, AWE, and EDF. Slide 9 gives us an overview of the topics that we're going to discuss today. So we've identified 5 areas that we think research could usefully be done in, that you guys could think of PhDs for. The list here, I'll just go through them quickly, and then we've got a couple of slides on each one. So firstly, technologies for waste package monitoring during surface storage. Secondly, performance of metal containers not made from stainless steel. Thirdly, methods for more efficient application of the waste hierarchy principles of reuse and recycle. Fourthly, development of alternative treatment technologies to improve packaging processes. And finally, determining the rate of release of tritium from solid waste under ambient conditions and the factors that affect it. Slide 10 takes us to the first of these, that's package monitoring during storage. So packages of higher activity waste are manufactured in advance of the availability of a geological disposal facility, or in the case of Scottish wastes, manufactured for surface storage. They're likely to require long-term storage. So current schedule for a GDF is for it to open in 2040. There is no guarantee that all wastes that are packaged at that time can be accepted immediately, and so stuff will be stored for potentially many decades. Even in a GDF, the packages may require monitoring. So it says here, for example, prior to final closure. What we mean by that is some of the vaults will be left open for a while, and during that period, the packages will need to be monitored. We need to monitor package integrity and aging processes in order to confirm continued suitability for storage, and ideally also track any observable aging trends. The existing higher activity radioactive waste. Existing manufactured HAW waste packages are metal containers, that's stainless steel and ductile cast iron, or concrete containers. The waste that's been encapsulated is mostly based on cement encapsulation, supercompaction, or in the case of high-level waste, vitrification. And PhDs concerned with the application of in-cell monitoring technologies would be relevant to this topic. Slide 11 moves on to the next topic that we've identified. That's non-stainless steel metal package performance. So as I said previously, most HAW waste packages are manufactured using stainless steel or concrete. Other metals could be used if specific performance requirements can be met. Ductile cast iron in thick sections is an existing example of this alternative. Another example could be carbon steel. The images there just show you on the left-hand side, there's a stainless steel example, that's a 500-litre drum. And on the right-hand side, those are ductile cast iron containers, or possibly also known as robust shielded drums. In historical option studies, other metals have not been favoured. That's, for example, on grounds of cost, longevity, mechanical properties, etc. But we'd be interested in knowing, could other metal containers be enhanced or confidence in them improved to meet the performance requirements? And PhD studies that would assist in doing this are sought. Slide 13, that's on applying the waste hierarchy. So development of methods to more efficiently apply the waste hierarchy principles of reuse and recycle are sought. So that may include efficient methods of sorting and segregating of waste, decontamination, reuse or recycle processes, and these typically consider contaminated waste materials such as metal, concrete, and soil. We've got a little image of the waste hierarchy on the right-hand side of that slide. I guess up at the top, waste prevention, very cheap. Down at the bottom, disposal, quite expensive. And so we're aiming to move up the waste hierarchy towards waste prevention. And that's the strategic preference. And that also reduces the environmental impact. Slide 14 just continues that. So the nuclear industry used considerable amount of steel in the construction of chemical facilities and reactors. And the question here, could it be decontaminated or reused? For example, plutonium-contaminated steels may be decontaminated by remelting, where the flute fraction will readily partition into metallurgical slag. Recycle of waste, so large volumes of stainless steel, copper, and mnemonic alloys, could they be recycled? Large volumes of concrete there as well. Under sorting and segregation, so in the past, waste were often mixed without thought of recovery, and being able to sort and segregate by material and or radioactivity may provide more efficient packing and reduce costs. And lastly, their decontamination to reduce the bulk activity of the material. The next topic is on slide 15. That concerns alternative waste treatment technologies. So we've got a very diverse mix of wastes, chemically, physically, radiologically, and mixtures thereof. And the volumes and types of waste vary from site to site. Cement encapsulation is the current baseline, but some wastes are not so amenable to cement. So it's got some examples there on amphoteric metals such as aluminium and uranium, oils and organic materials. New processes could reduce volumes and numbers of waste packages and improve waste performance. The next slide, slide 16, takes that a little bit further. Recycle of wastes. So we've already said, there's large volumes of stainless steel, copper, pneumonic alloys, large volumes of concrete. Could they be recycled? Some of the sites also have small volumes of waste, typically hard to treat by conventional routes. So there's mercury, oils, resins, sludges, etc., or mobile and high throughput technologies that could help to achieve that. Any new product needs to be verified for performance, and the mixed waste is often poorly characterized. So looking for processes perhaps that are insensitive to input, methods of easily sorting and segregating the waste. So anything that would help to achieve that, any research topics on that would be welcome. The last area that we've got there is tritium migration and the factors that influence it. So we don't have a great understanding in this area, and this inevitably leads to conservative assumptions being made when we assess, for example, doses. And that has an impact on transport assessments that we at Radioactive Waste Management do. And that could lead to more conservative advice being given when it comes to packaging. And so if we can reduce those conservatisms and improve the advice, that would be very beneficial. And so what we desire, as it says there, is a better understanding of the tritium release rates from common waste materials, for example, stainless steel, concrete, and magnox. And as it says, this would result in better packaging advice and potentially cost savings. I think that's a quick run through of all of our topics. I don't know whether, Lorraine, you want to pick that up or whether we go straight to Q&A.
That's great. Thank you very much, Martin. Yep, we'll open up to questions. So as I mentioned before, you can press *4 to unmute, and you can also type them in on the Blue Jeans software for any questions that you might have. Whilst people are just having to think about the information that's been provided and the 5 key areas where you are hoping to receive PhD proposals in there, could you recommend any background documents, particularly linking to the latest information of the volumes of waste, where people could go to get the reference information that they need to support their proposals?
Yes, I can certainly do that. So the inventory data for all of the radioactive wastes from existing facilities is published in the UK Radioactive Waste Inventory. That's published jointly by the NDA and DEC. The latest published version of that is the 2013 Radioactive Waste Inventory. It's updated triennially at the moment, so the 2016 iteration is currently in the works. With relation to inventory for geological disposal, RWM produce an enhanced inventory, if you like, for that takes into account additional things like potential new build reactors. The latest version of that is the 2013 derived inventory. That's available on our website. And as with the UK RWI, it's updated triennially, so typically following the UK RWI. So we will be working on an update to that shortly as well. So there'll be a 2016 iteration coming out. Further information, just from a geological disposal perspective, the RWM has its generic disposal system safety case, which is also available on our website. Lisa, I don't know whether you want to add anything to that. Sorry, was that a question?
Sorry, it's Matt Buckley from the NDA. I was just going to add a couple of other references that might be useful to people. So the first of those, the NDA strategy, obviously there's a section in there that talks about our integrated waste strategy, so that might provide some useful information on areas of particular interest to us. We've also produced the higher activity waste treatment framework that's been published recently, which goes into a little bit more detail on some of the specific areas of work that we're focusing on currently. And we've also recently published a higher activity waste strategy document. Again, just a bit more detail on the areas of waste management that we're interested in. There's also the stores guidance document that's been published. So there's a higher activity waste storage guidance document. So if you wanted more information about the storage of radioactive waste, then that might provide some useful information.
Lorraine, should we send you the links to these for you to put up alongside the webinar? Is that useful?
Yes, that would be wonderful. Thank you very much. Lisa, do you have anything to add from your perspective?
From the Sellafield perspective, well, we actually feed into the national inventory. So in terms of an overall picture of wastes and to make it estate applicable, that's probably, from our perspective, one of the best sources. However, we do, on direct contact, have decommissioning mandates which do future projections, which we can share out some of the information from that. From our perspective, some of the sources of not necessarily the waste routes that are existing for existing wastes, but an area of great concern from our perspective, it really is those problematic wastes, finding ways and solutions to the challenges that we have for waste that don't necessarily go down conventional routes or into conventional processes at this point in time. That's really, I think, the other places where there's information we publish every year through the NDA. I think all the other license sites do. Our T-BIRDs, our technology baseline documents. So that sort of shows the areas of interest for each of our key plants on site where we are seeing our future R&D going. So that gives a good suggestion of the types of themes and areas that we're interested in. And that's probably all I would input at that point.
Okay. Thank you very much. Do we have any questions from participants? So we'll give people just a few more minutes to collate their thoughts. I'm hoping that you found the session this afternoon useful and informative. So the aim was there to give you an overview about the NDA bursary call, what their main ultimate aim is, and how to kind of pull that together in terms of what they're looking for in those proposals. Following on from that, we had a technical presentation on the waste package and storage group within the NDA bursary call, and that highlighted the 5 areas of interest. I'd like to thank the presenters very much for their participation and preparing the slides for this afternoon's session. Okay. On one of the, I think it's on the question and answer session slides, you'll see an email address there. So that's for Mark Bankhead. He's one of the technical leads working in this area. If you have any questions afterwards that you'd like to send to us, please contact Mark. It can be about the waste packaging and storage group or any of the other groups, or about the bursary programme in general. Just send them all through to Mark and he will ensure that they get to the right person. I'd like to remind everybody that the closing date for PhD proposals is the 21st of October at 3 p.m. And we have an online system now for those applications, which is different from last year. So do please log in, get yourself familiar with that system, And if you have any problems, any technical concerns, please do email Mark. The next webinar that we have planned is on the characterisation group. So that is on the 21st of September at 12 noon. You can find all the information and registration information on the NNL website. So now we just have the last slide, which is kind of how to follow NDA on Twitter and things like that, and LinkedIn information. Okay. Right, well, we'll close the webinar at this time then, as we don't have any questions. And as I said, I hope that you find it very useful. Thank you very much for attending. If you do have any feedback you'd like to give us, also send that to Mark. He loves receiving those emails. We'd be really grateful to hear your thoughts, if you did find it useful or not useful, to support us in continuing to have these webinars to help and support you when you are writing your proposals for the NDA bursary call. Good luck and thank you very much.
Thank you.
Thank you.
All right, thanks, Lorraine.
Thank you.
Thanks a lot. Bye-bye.